Good evening, guys. Welcome to the first complimentary session of Cloud Data Engineering. So, as we already talked about the broader aspects of Cloud Data Engineering, what are the different areas that we are going to cover, the scope of Cloud Data Engineering, and how we kind of walk through the different modules that we are going to cover. So, I'm going to start a little quick with going through the course curriculum one more time, and then quickly we will discuss about the overall code the syllabus of cloud data engineering, what are the things we are going to cover, and from there we are going to start our first session. So are you guys are excited?
Yes,
Yes, we are.
yes, sir.
Okay, thank you. So let me quickly share my screen, and I know the brochure that we have covered already, but let me quickly walk through the curriculum one more time for the folks who hasn't joined our last webinar, and from there we can we can take it. Okay. So as you guys know that we are, as part of this course, we are going to cover cloud data engineering from a broader landscape, and there are different components that are associated with cloud data engineering. So first, we are going to start with the cloud data warehouse fundamentals. Like, what are the fundamental aspects of cloud data warehouse and cloud data engineering? How the big data overviews, what are the primary objectives of big data, and how in different industries big data is being handled. And then the Hadoop architecture, right? That is kind of the core architecture that has been followed across different industries for last 7, 8, or 9 years. And then we will quickly talk about what are the loopholes or the fallbacks of Hadoop architecture and Hadoop, and why the industry is slowly going towards data lake architecture, and going to the different cloud infrastructure in different cloud services like Azure, AWS, and GCP. Then we will quickly talk about what are the cloud data warehouses services that we have in different cloud providers, and how we can integrate those cloud services across industry. Okay. So after this, we will move towards Azure Databricks. Azure Databricks is kind of the heart of the cloud data engineering in US or in North America. I guess I have mentioned this in our earlier webinars. This is kind of the one of the most important topic that you can expect in most of the interviews. A lot of questions are coming from this particular topic, and in your day-to-day programs, you can expect a lot of Azure Databricks, Spark, and PySpark use cases. So as part of this, we will quickly go through what is the Apache Spark framework, how Databricks come into the picture in Spark, what are the different ways we can create Databricks workspaces, what are the delta tables, how we can create Spark clusters, and how to create data frames, right? And how we can use different transformations in Spark data frame. Okay. Then we will quickly cover the transformations of data frames, different actions associated with the data frames, and then the different tables, right? Different tables types. What are managed tables? What are external tables? And how these tables are fundamentally different from each other. Then we'll quickly go through Spark Web UI, different features of Web UI, how we can tweak the performance tune, how you can tune the performances through Spark UI. Okay. Once that is done, we will go through the different Spark data types, and then aggregations in Spark, how to create data frames, and how to use those data frames in different kind of Spark aggregations. Okay. Once that is done, we will cover Spark joins in depth, right? Spark joins is again one of the key aspect of Spark or PySpark. So we will cover in detail. And then we'll go through the different internal optimization techniques of Spark, and then we'll slowly cover to the advanced Spark and Spark streaming. Okay. So once those are done, we will slowly move towards Snowflake. As you know, Snowflake as a software as a service is kind of getting good traction in North America, and a lot of cloud providers are in fact integrating Snowflake with AWS or their Azure services. So we'll get to know what is Snowflake, what are the different stages that are involved in Snowflake, what are the different rollback mechanism, commit mechanisms that are available in Snowflake, what is slowly changing dimensions in Snowflake, right? How CDZs are getting captured, then the zero copy clonings, time travel, fail-safe properties, those things we will cover in depth. Okay. And after that we will see like how batch processing and data streaming is being done in Snowflake. Okay, so there is a very beautiful feature in Snowflake called Snowpipe, through which they can integrate the real-time data operations. Okay, so we will see some use cases on Snowpipe, how we can integrate data near real time. Okay, and then we will cover the Snowflake task. So once Snowflake is being covered, and then we'll move towards Azure Data Factory. As you know, this is kind of the ETL of Azure. Whoever doesn't know about ETL, it's called extraction, transformation, and loading, right? So in Azure, this particular data factory service is being heavily used as one of the ETL service, where we will see like how to create different data pipelines, and then how to create data flows, how we can use incremental and batch pipelines, how to use connectors, okay, different kinds of connectors, and then the different activities, right? Data movement, data transformations, control flows, those things we'll cover in depth. And then there is a very important feature. A lot of interviews are like, in most of the interviews, people ask this: how we can parameterize the data flow jobs, and how to execute those. And then we will cover pipeline monitoring, performance aspect, performance optimization of data factory, and then the integration runtimes. So once this data factory is being covered, we will discuss Azure Synapse, and how to create Synapse, and how to how it's being used in data warehouse. We will cover integrating data factory and data bricks. Once that is done, we will have a overview of cloud DevOps and CI/CD, and how to use CI/CD in our pipelines, and how we can create, like, push our codes in Git through CI/CDs and all. So those things will be covered in detail. So once all these things are covered, then the last thing is to have an hands-on project experience, right? So we are having a couple of projects, where first we will discuss the project, the problem statements, and after that, you guys will be given a week time to submit your project. Okay, before that, we will explain in detail the problem statement and what are the services that we need to use and all. So once after completion of your project, we will discuss that in detail, and the detailed solution also will be provided. Okay, on both the projects. So this is kind of a high level overview of the course that we are going to cover. Once the course gets over, it's kind of 3 months long program. And this is the first complimentary session. We are going to offer first 3 sessions as complimentary. And after that, we are going to, start with all the curriculums. So having said that, once the course is over, then we are going to provide you some certification prep guide, which will enable you to appear for certifications. First on the Databricks side, and then on the Snowpro side. Once you cover both the certification, then we'll help you to cover as your data engineering certification. So these 3 things are in pipeline. And along with that, we will provide you a resume, which will be kind of ATS, which will have a high ATS score, and also will provide you the interview prep guide. So that is kind of an holistic curriculum based out of 3.5 months. Okay. So any question, guys, till the point, the course curriculum and all, any question? Do you have any question? John, Avas, Candy, Gilda, feel free to ask.
No questions here.
Okay. Thank you. Nargis, Muhammad.
No question.
Okay. Urvi. Sorry if I missed anyone. Okay, cool.
So
So all are
3.5 months, do you think is enough to cover all the technologies that you just mentioned? It seems a lot.
yes. Is it Muhammad?
Yes.
Yes, you are correct, Muhammad. It seems a lot, but don't get overwhelmed. Just follow whatever is being taught in the class. And I am a great believer of, clearing the concept and having an hands-on exposure, hand to hand. Okay. So both the things will, you will practice each and every topic. We'll have hands-on session along with we'll have doubt clearing and concept clearing sessions. So just follow the path, whatever curriculum or the models that would be taught, and every after every class you will be provided with a recorded session. Okay, so I would highly recommend to go through the recorded session 1 or 2 times, and then along the path like start practicing all those things. If you do it, if you give proper commitment for 3 to 3.5 months, definitely you will cover most of this.
Now, how many classes per week?
So it will be 3 classes per week.
3 classes means 3 hours?
Yeah, 3 to 3.5 hours. Yeah.
Okay. So, and and as programming language perspectives, will you cover SQL, Python, Java, or something? What?
So as from the scripting and programming language perspective, I'm going to cover Python as part of PySpark and SQL, these two. For SQL, I'm going to give you guys some exercises and study materials, and Python I'll cover from scratch.
Okay. Thank you.
Okay. Thank you. Anyone else? Any question till now? Okay. If not, then slowly I will move towards the first session, which is the fundamentals of emergence of big data, how big data comes into picture, and from there we will discuss like what are the different aspects of big data that we have, and then from there we will slowly get into Spark. Okay, so before that, I just wanted to quickly ask you guys like three things. Okay, your name, the city from where you have joined, and why do you wanted to participate in cloud data engineering program. Okay, so I just want to have these three ones. So John, if you can start.
Yeah, well, my name's John Christensen. I'm joining from Waterloo, Ontario, Canada. And I've always been interested in data. I've been in IT for quite some time and contemplating a career change into data engineering.
Awesome. So may I know you are in which domain of IT you are currently working?
I'm on the application side, so I'm not a developer, but more of an integrator. So I
Okay,
do a little bit of sysadmin, a little bit of database, a little bit of cloud, and a lot of coordinating all those things.
awesome, awesome, perfect. Thank you, John. Aishwarya.
Yeah, hello everyone. So I'm joining from New Jersey, United States. I'm currently working as a cloud data engineer, so I want to explore more on that. Learn like Databricks and Azure Data Factory. So I just want to explore more and then I think from this course, I would
Perfect,
get this
perfect. Thank
opportunity.
you. Thank you, Ishwarya. So may I know which cloud platform currently you are using?
I have used AWS. I have
Mhm.
also touched a bit of Azure Data Factory and GCP, but not much on, not in deep, like the one that I work for the AWS here. So I think from this course, I can do that.
Perfect, perfect. Thank you, Ishwarya.
Thank you.
Arsalan?
Sorry, just it was muted. My name is Arsalan. I'm from Toronto, Ontario, Canada, and I'm excited to get hands-on so many topics which you have mentioned. I have a good experience with the databases, almost 30 years work. Plus, I know the Azure very well, Microsoft Azure. I was doing the administration of Azure when I was working with Sensia Global. And that's it. If you have any question, you're welcome.
Perfect, perfect. Thank you, Arsalan. So with your experience in databases and different, admin services, definitely this course will help you a lot. Thank
Yes,
you.
of course.
Thank you. Thanks for
Welcome.
joining.
Welcome.
Gilda.
Yes, good evening, everyone. My name is Gilda, and yeah, I'm interested in understanding and learning a little bit about AI and how it interacts with databases, etc.
Okay, perfect, perfect. Thank you. Ayush. Okay, we'll come to Ayush. Mohammed.
Hey, good evening, everyone. My name is Masood. So, actually, I used to work as a QA automation engineer for Department of Homeland Security, where I work in developing a Azure cloud-based data analytics platform. And over there, actually, I came to know all these technologies like Databricks, Data Factory, Data Lake, all these kind of things. And from there, I got interested switching to a data career. And as a part of this, I started learning some data technologies like, for mostly for data analytics, Microsoft Power BI, then SQL, Python, some machine learning models. And actually, my ultimate goal is to be a data engineer, though I didn't try data engineering so far. So that's my background, actually.
Yeah, perfect, perfect. Thank you, thank you. So Homeland, as I believe, Homeland Security mainly uses Azure services, right? As their
Right,
product.
Azure, right. All are Azure, right.
Right. So most of the government organizations, like be it in Canada or in US, what I observe is they prefer Azure data stacks. Okay, mainly ADF, data factories, Databricks, and Power BI. They heavily use it.
Right. Though they also integrate this Tableau. Yeah, so they integrated all different kind of all possible data analytical tools, including beyond Microsoft Fabric like Tableau, but it works on Azure.
Right, right. Yep. Okay. Thank you, Mohammed. Okay. Mir. Okay. Nargis. Okay. All right.
Hello. I'm so sorry.
Yes.
Yes, I'm mute. And actually, my name is Nargis, and I have been in the data engineering and data field for more 10 years. And I have a strong experience in data engineering, Power BI, SQL, and Data Factory, and recently become interested in the field of AI. And I'm so excited that I'm here with you. Thank you.
Awesome, awesome. Nice to have you, Nargis. So may I know, you have worked in only Azure stacks or in different cloud service?
Both of them.
Okay, okay, awesome. Thank you.
Thank you.
Nice,
Thank you.
nice to
Thank
have
you.
you.
Thank
Yep.
you.
Okay, so I hope I have covered everyone. Anyone got missed? Please feel free to introduce.
Uh, yes, my name is Aves. I am joining from Mississauga, Ontario, Canada. My recent past experience as a backend developer, but now I'm transitioning to cloud data engineering. That's why I'm here and part of this sessions.
Thank you, Avas. Welcome, welcome to our course. Thank you, guys. Anyone else left?
Yeah, so I'm Candy. I actually am in Phoenix, Arizona, in the United States. I've been a data engineer for over 25 years, but it's mostly been on-prem. I've done a little bit of work in the cloud with GCP. Airflow is the ETL tool, and Composer and some stuff like that. But I was interested in hearing about like how AI works with all of this stuff.
Awesome, awesome, Candy. Awesome. It's great to have you. First of all, let me tell you one thing. Phoenix is one of my favorite city. I've been there twice.
Awesome.
Yeah, I've been there twice. And especially sitting here in Canada, I love the winter of Phoenix. Like,
For sure.
okay, awesome. Nice to have you. So, may I know, you have been working in which industry, like which tech
So
sector?
I worked in healthcare for most of my career, but the last couple of years I've been working for the Department of Defense,
Mm-hmm.
working for the Air Force and the Navy on their defense systems. And the stack that the government uses for the Department of Defense is AWS.
I see.
Yeah, I mean the medical field was GCP.
I see. Yeah. So Phoenix as a city, as I know, right? It's a growing market, and a lot of companies have moved from Bay Area to Phoenix. If I'm not wrong. So you
Yeah.
get a lot of good opportunities in the cloud data engineering.
There is quite a few. I'm struggling. I don't have a role right now, and I'm struggling to find a role, I think, because, I'm not very strong in Python. I could write
Mhm.
anything in SQL, but Python's fairly new to me, so that's a little bit of a struggle, especially
Sure,
after all these years.
sure. Maybe after completion of the course, you will give all of us a good news. Okay.
Thank you.
Okay. Thank you all. Okay, so let's get started, folks. Okay. So this is the first, the first chapter, you mean to say, like the first foundation of cloud data engineering. So here I am going to discuss the core concepts, how cloud data engineering came into the market, right? What are the previous technologies that the industry was following? As most of you, whoever has been working in the data side, right? All of you must be knowing it, right? That starting from 2010, 11, 12, there is a huge demand. There was a huge demand on big data, right? So big data came into picture, and then the framework that supports big data, right, which is Hadoop. Hadoop was a kind of was a sought after technology during that time. So I'll slowly follow the trend, like how in industry, in different software engineering applications, that data landscape come into picture. Okay, so if you see, right, software engineering overall as a landscape, there are different aspects of software engineering. The first is the system software or the programming tools, right? Different programming tools currently we have, let's say Java, let's say Scala, Python, right? Objective-C, all these programming languages that are there that are interacting with different applications, right? Then we have a standalone desktop applications, right? We had data processing applications, different web and mobile applications. Like, as you know, with the advent of Y2K, right? There are a lot of web and mobile applications came into picture, and a lot of development happened on those areas. Then slowly, cloud computing came into picture, and now there is a huge demand on cloud computing, data engineering, cloud data engineering, and machine learning and AI or Gen AI on top of this cloud services, right? So if we have to look back, right, as a programming language, right? So first programming language which came in late 60s or late 50s was COBOL. Okay, it's called Common Business Oriented Language. I'm not sure whoever has worked on mainframe or not. So if anyone has worked on mainframe, you guys might be knowing it, that COBOL is one of the primary language which is used in mainframe, right? So this is a kind of the first programming language that is used for business data processing. Okay, that is kind of an first, you could say, primitive language through which we can process the data, we can store the data in a file. So the first concept of storing the data in a file comes through COBOL. Okay, so through COBOL we can store the files, store the data in a file. We can create different indexes, right, among different files, and then through mainframe we are able to transfer the files from one application to another through COBOL. Okay, so this is kind of the first stepping stone or the first programming language that we had that is mainly used for business data processing. Okay, so if you see, it is specifically designed for business data processing. And through COBOL, we used to, store data in files, create index files, and process data efficiently. Okay. So till 60s or early 70s, COBOL was heavily used, and it's been used to store the files, store the data in different files, and to have some indexing across different files. Now the real problem arises when we had to have a proper relationship across different files. When data started to grow, we need to have a proper relationship, right, across different files. So that time COBOL has struggled a lot. Okay, so during that time the concept of relational database came into picture, right? Where what is relational database? Relation stands for tables, storing data in different tables and joining the tables, different tables with different condition, this based on certain relations. So this is all about relational database. So this concept came in where we started to build tables, we started to create different tables, we started to create different keys like primary key, foreign key on top of a table. Okay, and now we have the relational databases have evolved to store the data in different tables and have a solid relationship across the different tables. Okay, so in that respect, Oracle was kind of the pioneer, right? In whoever has worked on the data field must be knowing it. Like Oracle was kind of one of the first provider where they heavily use relational databases concept, where through that we can create tables, we can have one-to-one, one-to-many different kinds of relationship across different tables, and then we can use like the structured query language or SQL, through which we can execute different commands where we can load the data in different tables, we can process the data, we can index the data, and we can retrieve the data. So all these things started to coming into picture through Oracle. Okay, so if you see, COBOL was designed in 1959 and Oracle was founded in 1977. So the reason I'm covering these things to give you a proper understanding how what is the evolution of this data industry, right? How relational databases come into picture, and from there how Hadoop come into picture, and from Hadoop how the modern cloud data stack come into picture. So I just wanted to give you an high level overview so that you guys able to connect the dots. Okay, so Oracle was founded in 77, and it was kind of one of the pioneer RDBMS during that time, and still till now Oracle is heavily used in the data landscape. Okay, so it was all good during late 90s and early 2000s. It was all good. People are using Oracle and the Microsoft SQL Server to create tables, load the data in tables, establish different relationship across tables. All these things were working perfect. Okay. Then in the early half of 2000, right? We had a huge demand on web and mobile application. So huge amount of data started to build. Okay, there's a huge data that started growing, and there was some system that is kind of required to store this data. Okay, and RDBMS is kind of falling behind in this aspect because there are some performance issue. The kind of data that was getting generated through web or through mobile applications, RDBMS or Oracle was not able to handle those data properly. Okay, so that time the concept of big data came into picture. Okay, as you most might have heard this term, the 3V of big data. Okay, what are the 3V problems of big data? So because of this advent of web and mobile applications, the volume of data has grown exponentially. Okay, so there is a volume aspect of it. Second is the variety of data. So earlier, when we are talking about relational database, we were only talking about the structured data. That means we have a proper row, proper columns, and the data are quite structured, and we are loading the data in a structured fashion. But now, with the advent of big data, we started generating a lot of unstructured or semi-structured data. So what is semi-structured? Let's say a JSON file. In web applications, if you are submitting a form, or if you are building or if you are creating a form and submitting it, the at the back end, there's a JSON file that gets created, right? There are times an XML that gets generated. So JSON is a concept of, you mean to say, a semi-structured data set. Okay, so you cannot properly formulate a structure. So that is kind of a JSON. XML is a concept or an example of an unstructured data, right? So XML files gets generated. So for a normal RDBMS system like Oracle or SQL Server, it was getting difficult to handle those kind of different types of file. So this is a variety problem of big data. Okay, along with that, there is the third V, which is velocity, right? So huge amount of data are getting generated at a high speed. Okay, and there is a requirement of a system that should accommodate this huge volume, and which is coming at a very high speed with the different kinds of data, not only the structured data, but structured, semi-structured, and unstructured data. So that time, the concept of Hadoop came into picture. Concept of Hadoop framework came into picture. It was and it was an open platform, like an open source framework, where there are some concept of many people, many organizations has contributed to develop this framework. Okay, so if you broadly imagine Hadoop, it has got three components. Okay, Hadoop has got three components. One is the cluster side of it. Like cluster is kind of the heart of the Hadoop framework, right? Like let's say the cluster is someone who handles, who manages the entire framework. Okay, so that is the cluster. Second is whatever data that are coming into Hadoop framework, we have to store the data, right? So that time this concept of data storage and data retrieval come into picture. And here the concept of HDFS or Hadoop distributed file system come into picture. Okay, so there is a cluster aspect of it which monitors the entire Hadoop platform. Next is the data storage or distributed data storage concept comes into picture, which is nothing but Hadoop distributed file system. So we have cluster, we have the data storage. Now there should be some processing engine that should process the data, right? So then the concept of MapReduce came into picture. In the early days of Hadoop, MapReduce was kind of got a good traction, and there was and MapReduce used to be written through Java or Scala during that time. Okay, now to be very honest, this MapReduce has now become obsolete, but I'm just giving you the context how these things are came into picture. Okay, so storage problem has been solved through Hadoop distributed file system, where we store the data across different machines. Cluster problem is being solved through YARN that we are going to discuss, which is the cluster operating system, and the processing of each of the files, right, is being handled through MapReduce, which is through Java programming language, right? So now in Hadoop, there are two different approaches through which we kind of handles this. So first is monolithic and monolithic approach. Second is distributed approach. So what is monolithic? What is distributed? So let's say during till early 2000, there was only a concept of relational database system came into picture, right? So that time, let's say Oracle or SQL Server, those are having a huge system of huge expensive servers that were there across different part of the world, right? So those servers are kind of the main system where data used to get stored. Now, let's say if there is a requirement to increase more data processing or increase more storage to store more amount of data. So that time, what you have to do, you have to bring the system down, okay, and then increase some more capability, like more processing power or more storage, so that it can handle more data or more processing. So that is called monolithic approach. RDBMS, typical example of monolithic approach is any of the RDBMS system. Okay, let's say Oracle, SQL Server, and then Teradata. Those are the concept of monolithic approach. Okay, so here if you see the left hand side of the picture, there is a one vertical server, and it has a secondary server. So primary and secondary server come into picture, and it's kind of expensive. If you have to make any adjustment, you have to bring the primary server down, make the secondary server as the fallback option, and then again you can switch it to primary. So this is kind of monolithic approach. This approach is again in industry term has been called as vertical scaling. So you are scaling it vertically, right? You are scaling it in a single system. You are scaling the system, like increasing the processing power or increasing the data storage. You are increasing it vertically. That's why it's called vertical scaling. There is another approach where Hadoop comes into picture, which is the distributed approach. So what is distributed approach and how it differs from monolithic approach? So in Hadoop, what they actually built is, instead of building a monolithic or single system, okay, they build multiple system, okay, which is multiple cost-effective system. All these system means these are computers, okay. So we have multiple computers. Those are cost-effective. Those are not expensive. Those systems are kind of getting connected with LAN. And then what they did is they distribute the entire workloads. They distribute workload across the different system. Okay. So it's a concept of horizontal scaling. It scales horizontally, not vertically, right? And it's economical because most of the computer that is being used, it's not expensive, it's economical, and it's multi-fold. So that what happens in Hadoop, the storage, right? If you see, we have 5 systems. So entire storage, if you let's say have 1 TB of storage, so it gets distributed across the 5 system. Okay, so storage gets distributed across 5 systems. Similarly, the data processing, right? So that also, let's say MapReduce, that also get distributed across 4 or 5 systems. So that all the workload will get equally distributed among the different worker nodes. So these are called worker nodes. Okay. So this has been distributed across worker nodes and it is fault tolerant, right? Like let's say if any system gets down, so that easily another system can be up and then can take the burden of the system or the system which gets down. So this is how the entire fault tolerance thing gets handled in distributed approach. So monolithic approach, distributed approach. One is called vertical scaling, another is called horizontal scaling. Hadoop is an example of an horizontal scaling system. Okay, and any of the RDBMS system, Oracle, Exadata, Teradata, these are example of monolithic approach. Okay, till this point, any question, guys?
Yes, I do have a question. So,
Yeah.
so basically, monolithic and distributed systems are the is the concept of application development, right? So is the concept is not the concept of how to use the database. Am I right or wrong so far? If
So
I
it's
am
both are, yeah, no, thanks for this question. So both are strongly coupled, right? If you are building an application, that means you have to store the data. Okay, you have to think about the processing power of that processing system, how you handle your processing system, how you store your data in these applications, right? So obviously it's an design or architectural thing, but it comes with your data processing or data storage part of it.
Yeah, then my next question. So, um, can't we use RDBMS with distributed architecture for microservices?
Right. I'll come to that point. Good questions. I'll come to that part. This is the first evolution of these approaches, but I'll come to that point. Yeah. Okay.
Okay.
Yeah. So till this point, we have monolithic, we have distributed approach, and we have, through this, we handle the scalability, we handle the fault tolerance, and we kind of handle how much cost we need to incur across this system, right? So now, so as I was talking about, so this is the database, okay? Both the things. See, right-hand side, we have this Hadoop system where data storage is being distributed across different machines. Okay, and we use MapReduce, and after that we use Hive. Okay, Hive and MapReduce we will discuss in later. So these are kind of the processing scripting language or the processing engine through which we process the data across different computer system. Okay, after that peak scripting came into picture, but now it became obsolete. Both peak became obsolete, Hive became obsolete, MapReduce became obsolete. Okay, but during mid 2013, 14, 15, during that time, these languages or these tools were very popular. Okay, and these are kind of act as a programming language interface or scripting language interface where it kind of interacts with the data. Actually, it use these scripting languages or SQL languages to export the data, to process the data, right? In Hadoop. And in the left-hand side, these are the typical example of RDBMS. If you see MySQL, if you see Oracle, if you see SQL Server, these are being used as a kind of a database and where mainly vertical scaling is being used. So now the Hadoop architecture, right? as I mentioned earlier. So Hadoop comes with the three components. One is the cluster management tool, which is YARN. YARN stands for Yet Another Resource Negotiator. Okay? Yet Another Resource Negotiator is kind of the cluster which handles the clusters, right? Second is HDFS, which is Hadoop Distributed File System. And third is MapReduce. So HDFS handles the data storage part of it. MapReduce handles the data processing part of it. And MapReduce comes with two components, mapper and reducer. Okay, so if you see, okay, YARN is the cluster resource manager, HDFS is the distributed storage, and MapReduce is the used for distributed computing. So overall, Hadoop platform was kind of being able to provide a distributed data processing platform. Okay, it provides a distributed data processing platform that was missing in the early days of typical relational database management system. Okay, typical relational database management system lacks in data distribution, where in Hadoop it comes with distributed storage, distributed computing, and cluster resource manager. So next is YARN. What is YARN? So as I have already mentioned, this is called yet another resource manager or resource negotiator. And YARN has mainly three components, which is RM, NM, and A. Okay, what is RM? RM stands for resource manager. Okay, which is kind of the backbone of the cluster manager or resource manager, which uses RM is basically the one which handles the entire resource management. Okay, node manager is another component which is used or which is present in all the worker nodes. Okay, and AM is the application master, which provides the cluster to run these different applications. So if I show you this diagram, you'll be able to connect the dot. Okay, so if you see this in Hadoop, as I already mentioned, it's a distributed platform where we have a master node and we will have worker nodes. Okay, so if you see in this is my client, and client will provide or send a request to the master node, and in the master node we will have resource manager as a main cluster manager. So resource manager will decide if any workload came into picture, if you have to process any data, if you have to retrieve any data, it will decide which worker nodes this work should be assigned to which worker nodes. Okay, so let's say there is a request came from the client and they need some data. So first it goes to master node, and this is the orange one is the master node, and these four are the worker nodes. These four green colored nodes are worker nodes. So master node will decide, let's say, second and the fourth one. These two in these two worker nodes, the actual workload they wanted to process. So it will send a signal to these two worker nodes, and then in these worker nodes there is a component called node manager. Okay, so node manager will accept this request in this third and the fifth one. It will accept this and it will create a container. Container is what? It's a virtual workspace. Okay, virtual temporary workspace that they will create to process the data. Okay, so the one highlighted in red, which is called application master, which is nothing but a temporary container, okay, that gets created in the node. So it will create an application master, and then the data will be processed, okay, in the application master. And then finally, once data has been processed, it will be transferred back to this master node. It will be transferred back to this master node. So the entire cluster management is being done through these three components: resource manager, which sits in master node; node managers, which sits in each of the worker nodes; and then the application master, which is present in some of the worker nodes where it will be that the actual workload has to be executed. Okay, through that the entire cluster framework has been monitored. So this is all about YARN, which is yet another resource negotiator. Next comes HDFS, right? So we understand how the clustering things is done. Next, we need to understand how the data storage part, right? How the data storage part is, coming into picture. So with respect to data storage, there are mainly two components. One is name node, another is data node. So name node is the one which resides in, again, which is the kind of the master of all the data storage, like resource manager. Okay, so resource manager or name node will decide in which of the worker nodes the file will be reside. Okay, the file will be placed. So if you see this particular example now, this will come. So here we have one master node and four worker nodes. In master node, we have resource manager as well as name node. Okay. Name node will dictate or will execute all the data storage functionality. Okay. Like let's say client sends a 1 terabyte file to a master node, right? Now this 1 terabyte file, you cannot store a particular 1 terabyte file to a particular machine, right? That file needs to be splitted, and individual splitting or individual component is called 128 MB. You have to split the file in the 128 MB each component, and then send this component to these data nodes. Okay, so if you see, this name node will transfer some of the files to this data node, node 1, some to node 2, some to node 3, some to node 4. This way, the entire files, the entire data gets distributed across the worker nodes. Okay, so that is the data distribution part of this system, and these are called data nodes, and these are called name nodes. In the name node or in the master node, we will have name node as well as resource manager. Resource manager is from the cluster point of view, cluster resource management point of view. Name node is from the data storage point of view. And then we will have data nodes, which is coming from the storage point of view. And then we have seen, like, if any particular worker nodes, in one of the worker nodes, data needs to be processed, then application master has to be created and gets executed, right? So this is how the data storage and resource management works. Next comes MapReduce. So MapReduce is a programming model or framework that has been developed, which is used for processing point of view, right? So let's say whatever data you got a data from client, you split the data into different files, and then you send the file to different worker nodes, right? Then each of the files stays inside these worker nodes. Now there has to be a processing engine or processing framework that should process those files, right? So in that respect, MapReduce comes into picture. Okay, and MapReduce has mainly two components. Okay, one is called mapper, another is called reducer. So through that, this mapper and reducer will get executed. Mapper is something, each of the worker nodes, mapper will get executed, and whatever is the result set, that will be transferred to the final name node, and then name node, the final reducer, okay, which will pick the results or intermediate results from the different worker nodes, and which will kind of club those components together and send it back to client in form of whatever data results that they need to check. So this is how Hadoop framework is kind of handles both the storage part of it, which is through Hadoop distributed file system, where we have name node and we have data nodes. Then the cluster part of it, cluster management part of it, where we have resource manager, and in each worker nodes we will have node manager and resource manager. And then the last part is application master, where you need to execute certain portion of the workload. There a temporary container will get created inside a worker node, which is called application master. So HDFS or Hadoop distributed file system, then cluster framework, and then the last is MapReduce, which is nothing but the processing power of Hadoop, where in each of these node mapper, each of the worker nodes, mapper will execute. It will process certain data. It will pass those intermediate results to the master node. And in the master node, finally the data will get, merged, and it will kind of send it back to the client. So this is how Hadoop architecture came into picture, which handles the distributed data processing. Okay, distributed data processing, and now we got to know that how this distributed data processing differs from the typical RDBMS monolithic approach or the vertical scaling approach. Here in Hadoop, we followed horizontal scaling, and now through this, we are able to somehow manage the problem of 3V, where a lot of huge volumes of data, so whatever data that are getting generated, that kind of we now through Hadoop framework, we used to receive those files, transfer the files across different data nodes, process the files, and while transferring or processing those files, it's not necessarily a structured files. We kind of now started processing structured, semi-structured, unstructured files, and the volumes of the files also, right? Those different files coming from different source systems are kind of getting loaded and getting processed through Hadoop framework. So that is the overall overview of Hadoop and RDBMS. Now this is kind of the initial stories of cloud data engineering, the distributed computing, distributed processing, and monolithic and distributed approach concepts came into picture. Now slowly we will see in our next class what are the fallbacks of Hadoop framework, how we have to get rid of this framework, what are the limitations of Hadoop framework, and then how the Spark application come into picture. Okay, all those things we will slowly start understanding the framework and how Spark came into picture, and how PySpark, Python as a programming knowledge language come into picture, which integrates with any of the Spark platform. All those things we will discuss in our next class. Okay. So till now, any question, whatever I have given you the introductory, any question, guys?
I have a quick question. Is this Hadoop still used in the industry today? Just because I know I was using this in the rail when we were doing a lot of our voice calling, and it was this kind of cluster where it had to rely on other nodes. So I guess aside from that industry, is this still used as one of the new technologies, or is something replacing this type of framework?
Yeah, very good question. So honestly speaking, Hadoop, most of the organizations whoever was there in Hadoop are slowly moving away from Hadoop, though they are using the concept like the distributed processing and distributed how data distribution was happening through Hadoop. They have taken those concepts, but most of the organizations, even in different banks also, they are kind of moving away. They have moved away from Hadoop to the cloud data landscape. But understanding of this concept, the basic architecture of Hadoop will definitely help all of us to understand the cloud data engineering framework. Like in today's world, whatever architecture that we are following, okay, this will definitely help you to understand how different services are being used.
Thank you.
I have a question. Sorry,
Sure.
I have a question. Is it the same as Databricks? Because Databricks follows the same structure, if I'm not wrong.
Very good question, Hassan. Yes, you are bang on. That is the reason I told you, right? That getting the concept, this distributed processing concept will definitely help us to understand this framework. Yes, Databricks is one of the company which actually they are the pioneer in Spark, right? So they are the
Yeah.
company which actually has written the Spark framework. Okay, and they in most of the cases they follow this distributed processing. You are correct, sir. We'll discuss in depth. Okay.
Okay, thank you.
Anyone else? Was it too boring, guys? Was it too theoretical, too boring? Forgive me, initial 1 or 2 classes would be like that. And after that, we will, start getting our hands dirty.
Sorry, I want to add that before going for the fourth session, I would like to know how do we work with lab if the material is always available, or after this course we don't have access to lab, or whatever will happen later.
Yeah.
So instead of presentation and just explaining that, again, I prefer the hands-on.
Sure. Don't worry. We will provide the hands-on and you will have an full in-depth exposure of all these labs. And these labs, again, these labs are different community editions that we will be following. So it's not related to our course, okay? After our course also, you have access to those labs. I will stepwise, I will, show you guys. So don't worry.
Yeah, thank you.
Okay. All right, guys. If you don't have any questions, so let's wrap it up, and then probably we will, we will again start our next session on Wednesday, same time, 8 p.m. EST. Thank you, guys. Thank you for attending the session. Sudhishji, you wanted to discuss anything? You are all good?
I have a question. So, will we get access to this recording? Like, if you want to look
Yes,
back
you
to
will
it.
get the recordings of each session.
Okay. So, is it like after enrolling, or is it like you give it today itself?
No, I guess I will ask my, team to, share this.
Okay, sure. Thank you.
Okay. Thank you, guys. Thanks.